Determination of aspirin. Experimental objective: to measure the percent of active ingredient, or acetylsalicylic acid, in an aspirin tablet. Week 1 objective: to create a standard absorbance curve using solutions of known concentrations of acetylsalicylic acid, forming your standard curve. First, in preparation of the stock solution for this experiment, you will need to prepare the acetylsalicylic acid by hydrolyzing it with a base. This reaction will form a salicylic dianion, which is really important for this experiment. The dianion is formed by boiling solid acetylsalicylic acid and strong base, which would be sodium hydroxide, together. It is very important that this reaction is carried out in the fume hood. Once the dianion is formed by boiling, that solution is diluted in a 500 milliliter volumetric flask. This is one of the solutions that you will use in forming the solution that you will use to make your standard curve. The other solution used is iron 3 chloride. When the salicylate dianion and iron 3 chloride solutions are combined together, they form a complex, which is known as iron 3 salicylate. This complex produces a purple-colored solution. When a higher concentration of iron or dianion solutions are combined together, there is a greater amount of complex which is formed, and thus a deeper purple color is seen in the solution. When a solution is a deeper color or more concentrated, more light is absorbed by that solution. The spectrometer measures the amount of light that is absorbed by a solution by way of Beer's law, which states that there is a direct relationship between absorbance and concentration of a solution. For this experiment, a spectrometer will be the instrument used to find the concentration of different solutions. In this experiment, you will use the spectrometer to measure the absorbance of solutions that you know the concentration of the complex ion in. From those absorbances and the known concentrations, you will make a standard curve for which you can use to help identify the concentration of an unknown solution. That will be week 2 of the procedure. To form the standard curve for this experiment, you will need to make several different concentrations of the iron 3 salicylate complex solution. You will measure the absorbance of these solutions with the spectrometer. To make these solutions, you must use a graduated pipette to measure and transfer the different volumes of the stock solution that you will need into a 50 milliliter volumetric flask. You must be as accurate as possible, because losing some of the solution will affect your calculations for this experiment. Once you have finished, there should be 5 50 milliliter volumetric flasks, each with a different volume of the dianion stock solution within it. Once you have transferred the different portions of the stock solution needed into the different 50 milliliter volumetric flasks, the next step will be to dilute these solutions with 0.02 molar iron 3 chloride solution. The purple complex will form once you add the two solutions together. Accuracy is key in this experiment. Make sure when you are filling the volumetric flask to be as exact as possible when reading the meniscus. After you have accurately diluted the solutions with the iron 3 chloride, invert the flask with the cap on a few times to properly mix the solution. Be careful not to spill. This process will be repeated to form 5 solutions of different known concentrations of the dianion. These concentrations are known because we know the concentration of the stock solution that was used in making the iron 3 salicylate solution. Because the reaction stoichiometry is 1:1, and we know that the salicylate ion is the limiting reagent in the complex forming reaction, we know what the concentration of the complex formed is because we know the concentration of salicylate ion from the stock solution. Because we know these concentrations, you can use them to calculate the standard curve. You just need to figure out what the different solution concentrations are. If the molarity of the stock solution of sodium salicylate is 1.67 times 10 to the negative third molar, you place 10 milliliter of the stock solution in a 50 milliliter volumetric flask, and then dilute it with 0.02 molar iron 3 chloride to 50 milliliters in the volumetric flask. You now have all of the information you need to calculate the concentration of the diluted solution using M1V1 equals M2V2. If you plug in the values that you know, You will then be able to solve for the unknown value in this equation, which in this case is the concentration of the diluted solution. Once you have calculated the concentrations of various iron 3 silicinate complex solutions that you have mixed, you can begin to make your standard curve using the spectrometer. Setting up the spectrometer is not difficult. Make sure you follow the directions that are given to you in the lab manual. Just a side note, it is important to wipe down the cuvette with a Kim wipe before placing it in the spectrometer. Doing this will help the spectrometer's readings to be more accurate, giving you better data. Better data equals better results, and better results leads to better grades. Accuracy is important. Once you have completed making your standard curve, the procedure for week 1 is complete. Additionally, there are a few important things to remember in this experiment. Make sure to carry out the boiling reaction of the acetylsalicylic acid and the sodium hydroxide in the hood. Also, when calibrating the spectrometer, make sure to use iron 3 chloride as the solution which you calibrate with. As with any experiment, it is always important to follow directions. They are there for your own safety as well as your classmates. Thank you for watching and have a safe lab.